So good afternoon, everybody. It's really a pleasure this afternoon to have our internal seminar given by Stefano. There's no need to introduce that also very well. And as you know, Stefano will talk about everything you always want to know about AI, but we're ready to ask. So,
okay, thank you everyone to be here. And this seminar is okay. It won't be a technical seminar. I mean, there are a couple of technical slides, but I wanted to discuss with you and to give you like a conceptual map about artificial intelligence, because I think it's the hot topic of the decade, and you will stay with us, if not forever, maybe for many years. And I think starting from this slide, you can ask yourself, why did they use AI to create slides? Well, I tried. This was the result. But I assure you that this is the only slide created by artificial intelligence. The following ones are all created by myself. Okay. So this is the outline. Let's begin with the definitions, because there is some confusion, especially if you read newspapers, if you read articles, internet sites, social networks about the artificial intelligence as a concept. You will see the difference between AI and machine learning, and I will present some algorithms and models. These are the technical slides. I won't dive into details. I hope not to bother you, but I will give you some hints just to understand how this model works. And then I will give a short introduction about large language models, ChatGPT, so to say. And then a little presentation about the current projects here, and a couple of proposals. Basically, it's the poster that we presented in Bologna at the Forum of Technologies. And then, if we will have time, I'm not sure, I prepared a bonus with the future of AI risks and threats to us. Could be interesting, but okay. So let's start, since it's English definition, let's start from the adjective. So what's artificial? You can see there, artificial of a thing made or constructed by human skill, especially in imitation or as a substitute for something which is made or occurs naturally. As you may know, the word derives from Latin, from artifex. Sorry for Italian, didn't find anything else, but I think it's nice this translation from a Latin vocabulary, because there are 4 different translations, quite different among them, because we have artist, we have expert, we have creator, but we have also a scammer. And I think it's perfect to represent it's perfect to represent what's AI now, which are maybe some agents of AI nowadays. And what you see there is the myth of Pygmalion and Galatea. Pygmalion created Galatea as a statue and fell in love with her, and asked to Aphrodite to give life to this statue. This is a common topic. Just to say to you that these common topics of creating something as imitation of a human, it's inside us since millennia. So it's very interesting. There is literature, plenty of literatures, like in the centuries. Like the Golem, story of Golem, Frankenstein. There are plenty of these examples. But okay, now what is intelligence? And here I think an universe is opening. I hope there is no expert of philosophy among you, because you will kill me. But okay, just this is just to show that everyone in its own epoch has given a different meaning of intelligence and knowledge, starting from Plato, Aristotle. We have cogito ergo sum from Cartesio, then Locke, Kant, Hegel, and then in the last century we have Heidegger, Wittgenstein. But our focus, my focus for this presentation is to that English guy, Turing, if maybe you already recognize him, which adopted what I can define as an engineering approach. So let's not philosophize about what is the intelligence, but create a machine which imitates the human behavior. So maybe we can understand better what is the intelligence. So now we have the famous Turing test, also known as the imitation game. Probably some of you have seen the movie. It is a test of machine's ability to exhibit intelligent behavior equivalent to that of a human. So probably many of you already know this test. We are the C, so we are the user that asks some question, and the answer is given by two other subjects in two different rooms that I don't see. One is a calculator, and the other is a human being. And of course, at the moment where I cannot recognize which is the calculator, which is the human being, the test is passed. And I will reintroduce this concept at the end of the presentation with the modern AI. So let's see at which point we are. Okay, so but what's the definition of the artificial intelligence as a field of research? It's a field of research in computer science that develops and studies methods and software that enable machines to perceive their environment and use learning and intelligence to take actions that maximize their chances of achieving defined goals. So if you think about this definition, it contains a lot of things, a real lot of things, because it is about perceiving the environment, it is about completing some tasks, it is about making what we define as reasoning. So it's really a wide, a huge field. This on the bottom, these are some funny memes. But I think they represent what is AI now in the media. So especially the last one. I don't know if you saw the movie The Wolf of Wall Street, but now if you want to capture the attention of the audience, okay, just put artificial intelligence in an article, and then you have probably caught the audience. But what is AI? When you see AI mentioned on mass media, is usually not AI. They use the term AI to represent to refer to algorithms, which are, as you know, previous than AI, and could be not AI at all. Or they refer to what we call now AI is only a subset of machine learning applications. You see, machine learning is the second one among the subfields of artificial intelligence applications. And in particular, they refer nowadays AI to, they mean deep neural networks or large language models. As I said before, it has begun like a clickbait scam. But, you know, my 2 cents is that AI as a concept is an everlasting leap forward. I mean, the field of research is all the same. I mean, what was AI in the 60s is still AI, but in the perception of the audience, what was AI back in the days is not even considered intelligent, and the contrary, what is AI now probably won't be AI more in some years, because the innovation has a huge velocity. So, but now we are in this decade that has seen the boom of AI. well, not AI, machine learning algorithms, to be precise. Why? The reasons are basically these four. So, big data, the data that's every second passes throughout the whole internet networks, and we are one of the major agents that give data for free through social networks or through other ways. We also have in these years the rise of the amount of the computational resources availability, some new brand technologies in GPU, for example, but not only, even many other technologies. We've had the introduction of new algorithms, techniques in the machine learning that enable the accuracy of the resolution of many tasks, and we have the easy developing. A guy with basic knowledge of Python programming, for example, can develop its own model of machine learning algorithm. So the real question is: so since when did AI begin to impact our life? Let me tell you this little story, personal, family little story. What you see on the left is the bomb from Alan Turing in Bletchley Park. As you may know, the English were captured one of the Enigma machine from the Nazis during the Second World War, and they used this machine built by the team of Alan Turing to decrypt the messages of the Nazi and of the allies, so of us, of the Italian army. And what you see on the right is the cousin of my grandfather, not a direct parent, but he was from Roseto. And what you see in the middle is the battle, an image of Battle of Cape Matapan, is in Greece. Maybe it's not so famous, but it's I think it's one of the most infamous and shameful battle of the Second World War from the Italian point of view. I won't tell the story now, but the Royal Navy fought against the Italian Navy, but the Royal Navy knew exactly which were the Italian battleships, which at what time they were in that point of the Mediterranean Sea. And as an example, after the battle, the English loss were 3. Just 3 people dead. You know how many Italians died in that battle? 202,300. 3 versus 2,300. This was achieved from AI, basically, and my relative died also in that battle. So I think it's nice to compare also to what they nowadays. You know, you already read the title AI in Gaza, AI in Ukraine, but it's all been from the beginning in this way. This is the machine learning definition. So machine learning, we already saw it's a subfield of artificial intelligence. In particular, it's a field of study concerned with the development and study of statistical algorithms. Attention here, statistical, that can learn from data and generalize to unseen data and thus perform tasks without explicit instructions. So now I will give a short presentation of some models, starting from level 0, the logistic regression. Okay, this isn't still AI, it's a step backward. What is logistic regression? It's a statistical model which estimates the probability of an event binary given a defined set of independent variable, binary or continuous. So as just to have an idea, this is the probability of passing exam versus hours of studying. In the x-axis, we have the hours of studying. The black points are the data of some students. As you can see, many students which didn't study, they didn't pass the exam, while other students, the amount is raising with the raising of the hours of study. And what's in the middle is the sigmoid. It's this function that maximize, and it has proven to be quite effective to represent this kind of events and this kind of problems. One can think, okay, this could be nice for simple binary classification, but what about if I have, for example, an images like that one, cat or non-cat? As you know, even images, digitalized images, can be represented as a vector of numbers, three matrices, red, green, and blue, and it can be used even with this model. Spoiler: this model doesn't work well with this kind of data because they are too complex for this model. So the idea was, and I'm speaking about the 40s or the 50s of the last century. The idea was to take this logistic regression and put inside a mathematical entity. And this was the famous artificial neuron, mathematical function considered as a model of a biological neuron in a neural network. The artificial neuron is the elementary unit of an artificial neural network. So basically, we have a vector of inputs. Each one of them is weight. The W is the weight, plus a bias that is often 0, so we can forget about it. This input is given to the sigmoid that we've seen before, and we have a result. We have a result that represents the activation of this neuron, the activation of this function. Just as a curiosity, people who invented this thing, they didn't have in mind the biological neural network. It was just a nice nice branding idea. So they didn't have in mind at the beginning the neural network, but then they saw, okay, this looks like the biological neuron, so we can name it after this. Okay, so each of these neurons can be put in a network. We have, of course, the input layers that represent the input data, the hidden layer that represents the layers in the middle, and the output layer. There could be one for binary problems, or there could be many nodes in the input layer for categorical classification, so with many classes. I won't dive into the functioning of the networks. What you can see there, it's the space of the solutions of the network. So the networks works in this way. It gives itself a representation of the input data that I feed into the network, and its aim is to minimize the error between the predicted value and the real value. So basically, the network must find the deepest well, so the deepest, the minimum, the global minimum, which is the error difference between the predicted and the real value. This is performed by gradient descent. So the model weights are updated through this kind of algorithm. And I don't know if I have probably this video. Okay, this is a nice representation, even artistic. This is the output level, and those are digits, so cipher written by hand. This is too much loud, maybe. Okay. This is basically how a network work visualized. So the inputs that represent the category activates throughout the path of the network, and this kind of architecture is pretty precise to resolve classification and regression problems, but it's accurated with 1D data, one-dimensional data like vectors. For two-dimensional data, it begins to have some problems of accuracy. So what they invented like 15 years ago, another kind of network. We are level 1 passed to level 2 convolution neural networks, and I'll show you another video, maybe. This was from 10 years ago. Okay, so how can an algorithm perform this kind of things? This is in real time, and this is an object classification and no recognition, call it whatever. So people, car, umbrella, and so on. So this is performed basically throughout two different processes. The first one is image segmentation. Basically, you have to find the edges of each object in an image, and then once you extrapolate the object, you feed in a neural network, which is the one architecture that we saw before. But how can you perform an edge detection task with such a maybe not a precision, but at least such a speed, for example, in real time that you've seen before? This is achieved by convolution neural network. This is I'll try to explain in few minutes the basic idea, because the basic idea is really simple. I would say even stupid, but it has a huge potential. What you see here is let's see. This is on the left. This is our image. For now, it's a grayscale with white on the left, gray on the right. And the other one is a filter which enables, which characterizes the vertical edges. So if I want to detect a vertical edge on the image, I can use this kind of filter. And what this network do, they take this filter and pass throughout all the resolution of the image and perform a simple operation. Basically, it's element-wise multiplication and then sum, like it's 10 times 1 plus 10 times 1 plus 10 times 1 is 30. It's 0 in the second column. It's minus 30 into the third column. The result is 0. Next step, the result is 30. You see, it's 30, 0, and 0. It's a clear, or maybe okay. Okay, the final result is this one. So the algorithm has detected an vertical edge at the center of the image, like the one that was on the original image. The white represents the feature extracted from the image. I know what you're thinking. It's thicker than the normal. This is because we use just a 6x6 image. With a real image, with a higher resolution image, it works perfectly. So basically, we can apply this kind of filters. We can invent, we can generate like hundreds of filters. And what the convolutional network does is apply these 3D filters throughout the images and extrapolate all the features of the image, starting from the simplest ones, so vertical edge, horizontal edge, and diagonals, etc. And then going through extrapolating the details. This is basically what a convolutional network architecture looks like. So we have an input image, and we have all these convolutional layers that filter out the features of the image, as I said before, the more simple, and then going through the details until we will have a flattened layer. So basically a vector with numbers inside that if we look at those numbers, they have no meaning for us. They have no meaning for us human, but it's a self-representation of the networks of the network referred to the input image. What does the network do? It gives this flattened layer as an input to a common neural network, the one that we saw before. So we have at the output layer classification output. Of course, we give those kind of classes before in the training, and we tagged during the training the input image with the classes, so that the network can build a representation of many images, classes, and tasks inside just one model. This I know this look well. It cannot be explained with analytical in analytical way, because you are asking, okay, but how does it work? It works. I mean, it's this is a common in machine learning, because the approach is data driven. So a guy invented this kind of network, and he didn't know if at the beginning this convolutional approach would have worked, but it worked at the end, and all the things that we saw nowadays referring to images treated in the AI context, they all use this kind of algorithms, this kind of model, the CNN, convolutional neural network. This is another representation. As you see, the image is shrinked until a flattened layer. Okay, level 3. Okay, we are going to classify images, but what if I wanted to generate new images without, of course, explicitly adding instruction to the model? So we dive now into the generative adversarial network, so the generative, what they call generative artificial intelligence. And in some kind of way, we return back to the Turing test, because it's here even a game against two different agents. One is the discriminator network. They are network like could be shallow or convolutional, as we said before. Discriminator network and the generator network. So the discriminator is fed with real, for example, here is we want to build a network that generates new faces, new human faces. Okay, we have a discriminator that we trained with real photos, with real human faces, it's a convolutional network, like we said, we seen before. And then we have a generator. So what is the idea? That is pretty clever and pretty. I think it's a genial idea, and this kind of network was invented by a postdoc guy like 10 years ago. We started from sorry, the spam is calling. We start from noise. Okay, the generator at the step 1 doesn't know anything about the problem that it is going to resolve, but we feed a white noise matrix, and then the discriminator, his task is to discriminate if this image generated from the generator is real or fake. Of course, at the first step, the discriminator will say no, it's fake, and it will give an error value back to the generator. The generator randomly correct itself, and it will give another image that will be at step 2 also some kind of noise. And this goes through step 1, 2, 10, 100,000. What we will discover at some point that the generator has become so good in generating, in this case, human faces, just learning from the error value given by the discriminator, that at some point the discriminator won't recognize anymore which is a real face and which is a face generated fakely from the generator network. And this is the even here it looks like stupid. It looks like just okay, with no strong basis, but the whole generative AI works in this way. And okay, we can continue to level n anything. So we were here, machine learning, you see deep learning. If I zoom in deep learning, this is all the, mostly all the models and the algorithms. We just seen the generative adversarial networks. If I zoom in, generative adversarial network, there are plenty of articles, plenty of people that have built their own generative network, and it is a real jungle. And basically, the point is that there is now a deep learning algorithm for everything, for every task that you can take. Maybe a step more, the large language model, a recent innovation in AI, in machine learning, that went viral in 2022 with the release of ChatGPT. Okay, I won't explain in details because it's a real complex model. But what you can take out from this slide is even here the basic task of this model. They work on word prediction. So they don't do reasoning as we imagine, but they just, given a sequence of words, they calculate the probability distribution of the next word. We have here, for example, listen to your, and then they have this list of words that they will choose in your in the answer that will give to your question, just in this way. The two key properties that distinguish LLMs from other language models: the quantity. The GPT-4 is expected to have more than 1 trillion parameters. Parameters, you can think a trillion nodes of the network. So that could be an idea of how they work. And the quality. This is a real interesting point, because when they were training these huge models. At the beginning, they were thinking, okay, I need to create a model inside this machine for language translation. I need to create a model for sentiment analysis. I need to create a model for any other kind of tasks. But then, with their complexity, the developers found out that the machine did these tasks by itself without a specific training. So the model could generalize many different kind of tasks without a human that has trained himself to do that specific task. How to use the large language models? So probably you are using in the very easy way. So ChatGPT, the user interface. So you ask something to the model, and you have the answer. There is another easy way to interact with the LLM directly. So not throughout the user interface, the website of ChatGPT, but through an API. If you have basic knowledge of programming, you can do this quite easily. And then we have a more specific way, the second, the model fine-tuning. For example, us, like Osservatorio Abruzzo, we can decide, okay, we want our personal large language model. So how to do this by ourselves? We can buy or load the base model from GPT, from OpenAI, from Google, from whatever, and stack our data on it. So, for example, we can feed into this model something that isn't on the internet, like our articles, like our I don't know, our library or something like that. So we can have a model that is quite that can generalize, but it's also focused on our database that we fed the model into. The third choice is build our own LLM. I think it's quite unfeasible. If you, I don't know if you can see the numbers on the right, but for GPT-4, just the training cost of these models has been $78 million. For the Gemini, like 191 millions, if I read correctly. So this is one of the reasons, because, for example, in Italy, we don't have our own large language models. The French has one, is called Claude. But in Italy, we have no such a big thing, because we didn't invest, and no Italian companies invested this huge amount of money into the developing of a property large language models. So we came back to Alan Turing test. These models, okay, are now indistinguishable from humans. It's hard to say, because it's hard to say. It is not clear whether they can be considered plausible cognitive models. So it has been shown that sometimes they can learn patterns that humans do not, but other times they fail to learn patterns that humans typically do. So it's hard to represent in one single test what they can do if they are distinguishable from human. And I put there a simple joke. Maybe I don't know if any one of you has the idea why ChatGPT is failing. I asked 9.11 and 9.9, which one is bigger? And the answer is 9.11 is bigger than 9.9. But then it does something, and then at the end there is a contradiction, but the real answer in 9.11 is minor than 9.9. Okay, why, in your opinion, the first sentence is wrong? Because
Number of digits.
no, could be, but it's not the main reason, but it could be.
It's a no,
No, this is interesting.
11 after the point. The number of digits.
It has nothing to do with maths. Not. It's nothing to do with maths. ChatGPT is fed, is trained with internet data, and it reasons with the statistical. So in internet, this example want to work with 8.11 or 7.11, just for 9.11. It has to do with an event, historical event.
It's the 11th of September, 2001.
Because the occurrences of 9.11 in internet are more the occurrences that which refer to 9/11, to the Twin Towers, not a number. Now it has been corrected, this kind of number. if you type this, now it works fine. But that's interesting because they work even when they perform operations. 5 minutes, okay. Maybe okay. It's okay. They don't have a mathematical model or a logical model. They only reason about statistics. So in this kind of things, 9.11 is for a large language model is it can be a date, it could be a number, it could be anything, and that's because it can fail sometimes. Okay, now a small section about the projects that we have in our observatory. This is okay. My objective, even for this seminar, is to stimulate ideas among us. Of course, maybe we won't have time to discuss now, but I think it's an important point to ride this trend, even if it's not a trend, but it has begun to widely used also in astrophysics.
Mi sente più? Sentite?
Io
No.
ti sento, ma non
io
sento
sento
gli
te,
altri.
ma non sento loro. Sì,
Ah, ok.
ho mandato
Sì, le-
anche una cosa in chat.
Anche io non sento più, sinceramente.
Non so se la vedono.
People from remote, there's some problem with the computer. Okay.
No longer.
The computer is back. We'll start
Ok.
soon
Ok, adesso.
again.
Yeah, it's weird.
Adesso insomma, ci stiamo ricollegando. No, you're not. I can see that. So we lost. Yeah.
You can see? Yeah. Okay.
Wait a second.
Vediamo la slide, ma non sentiamo.
Okay, now?
Sì, ora vi sentiamo.
Mi sentite?
Io ti sento,
Da
Stefano.
remoto?
Ok, sì, sì.
Ok,
Io ti
voilà.
sento, sì.
Okay, so in this kind of project we use
So you're fine.
okay. Okay, we use many of the models that we've seen before. We achieved a very interesting results for improving the images. So the nice thing is that we use to improve another catalog in the infrared to mass of the same portions of the sky. And okay, whoever is interested, we can talk later about this one. Then we have a Benedetta project, but you can talk if you want, because I know really really a few details about this thing. But okay, it's about aberrated wavefronts, simulations, and we use CNN, as you seen before, and Benedetta learned from scratch in 1 week, I think, something like that. So we have two other proposals, one from Piero characterizing these are still ideas, not anything done, but to characterizing craters throughout machine learning models of the one of Rebecca, even the classification dwarf galaxies, and can be both of those can be good candidates for using machine learning models. Then I prepared some slides, funny slides, maybe not funny, funny at all. But okay, the question is at what time, what point of time we are now in the AI progress, and this is I think a funny mental game. So imagine we are in a 19 Congress about the future of automotive, and there are two opposite factions. Cars will improve our lives forever. Car will destroy our world and kill us. So which ones do you think are right? Is right? The same. Yeah, I think both of them are right, because after 100 years, we've seen that, of course, cars have improved our lives, but we have seen also that cars can be a weapon. Cars can ruin cities and so on, ruin lives sometimes. So I think that this is the same approach that can be attached to AI. Now, really fast, I go through the risks and threats nowadays, but real now, if you open your smartphone, I think privacy and copyright, this is an example you've seen, of course, in these days, this trend. I grabbed this image from Google. I don't know who these guys are, but the funny thing is that I committed to a double privacy copyrights frauds, because I stole the photo from those guys. They put this photo, of course, on their social network, and I stole the copyright from Miyazaki, because ChatGPT has learned to generate images in the Studio Ghibli style without paying any copyrights at all, and this can be applied to any artistical prompt. We can talk about this for hours. Another problem, of course, is the dominance by tech giants. The power of AI algorithms reside in the data. Who owns the data? These guys own the data. Yeah, the wife, she went in the suborbital flight. Okay, the other one, power needs and environmental impact. We clearly know what's the problem. Misinformation. I think you already saw this image, and I think there's become a problem to distinguish between images generated. This is done by the GAN, Generative Adversarial Networks, that we saw before. This is, for example, yesterday with the teachers of high school, this was a real hot topic, because this is an example of ChatGPT. Show me an average American girl. So what you see there? You don't see any Afro-American girls, you don't see any Latin girls, and you don't see. And this is the bias of the algorithm, because on internet, probably inputs with this kind of thing with white girls are more common than other kind of aspects.
It's just the same.
Yeah, also, yeah, kind of, yeah. Okay, like a transparency, this is an image of what you see in a convolutional neural network. If you stop the process in the middle, so show me what's the images that you are processing in this moment. This is this is called like AI breathing, because you have no possibility to because of the complexity of the model to understand what is doing in a Okay, this is a common problem that acts with an eyes AI. Okay. This is about unemployment, also funny. I found this very intelligent this sentence. So I want AI to do my laundry and dishes so that I can do art and writing, not for AI to do my art and writing so I can do my laundry and dishes. Then the final questions, existential risk. So are we in danger? I don't know. I don't have, of course, an answer, but this is the answer. So we don't know, because, like I said before, ChatGPT has learned several problems without explicitly being trained to perform this kind of problems. So since we don't know exactly the mechanisms of self-consciousness inside ourselves, we cannot say if one day the machines will take conscience of themselves. So this is a big question mark. I think it's done.
So that's the second thing, and that was comparable safe.
Okay.
And if there are questions, please unmute yourself.
Okay, that's self-consciousness.
I think there are experiments, of course. I don't know exactly. I never studied this, but of course, yeah. Okay, they are experimenting. The funny thing is that you know that it has been proved that language models like ChatGPT cannot explain themselves, so cannot explain their decisions. For example, if I say to ChatGPT, okay, demonstrate this kind of theorem, okay, and it answers with a demonstration that can be right or wrong, but it's always statistical. Okay. And if I ask ChatGPT, okay, how do you achieve these kind of results? And it begins to say something that is not related to the resolution to previous questions. Like, yeah, I used this theorem that I found in the article in the book, but it has not used really that theorem because it has no a reasoning, a logic rules model. So
there are questions on remote. From here, Carlo Bacca, please unmute yourself and speak.
Hi. Thank you, Stefano, and bravo for this presentation. Can you hear me?
Wait a second. No, don't hear. Wait a second, Carlo. We can't hear you.
Prova Carlo, scusa adesso.
Can you hear me?
Yeah, we can hear you.
Thank you. Thank you, Stefano, and bravo for your presentation.
Thank
I would like to make a comment and ask your thought about just the last few things you said, autoconsciousness. I'm sure that you are aware that near the end of last century, a lot of work has been done in that direction, mainly in the logic and mathematical area.
Yeah.
For instance, there is a famous book from Hofstadter, Bach, which take into account some of the requirements needed for autoconsciousness. And the main take from him is that to have autoconsciousness, you need to merge different learning levels, learning and assessment levels, logical levels in some sense. And in this area, the logical structure of AI or ChatGPT don't make that part. You should make jump from a level to another to fulfill that. Can you comment on this, or have you some things thought about that part? Thank you.
Well, no, even when I studied artificial intelligence at the university, we still hadn't these kind of models, but we still rely on logical rule-based intelligence and the models even for robotics, etc. I think nowadays these new machine learning algorithms who are using statistical basically have taken over. So I think I don't know if there is still someone who is investigating deeply the logical base rule model. I don't have a strong opinion about the question that you asked. I mean, it's strange. It's how can I say? For specific problems, ChatGPT has already surpassed us as a human being, but maybe since years, artificial intelligence for specific problems has already surpassed. Don't know for a general intelligence, maybe a simple large language models will never be enough. Maybe we will need a robot who will perceive its environment with a language models inside itself or something like that. I don't know, but I think sooner or later we will come at that point.
Thank you.
Thank you.
Thank you.
Piero, you have a question? Piero,
Qui, sì, ci sono. attivo la camera. La mia è più che altro una riflessione, in realtà.
Why don't you say it in English?
È una riflessione sotto forma magari di domanda, ma parliamone insieme. Innanzitutto, bravissimo Stefano, veramente, no, ma cioè, appassionante proprio questo seminario. Ovviamente si sente parlare moltissimo di AI che devono in qualche modo imitare, simulare, che poi questa è un'altra parola su cui stavo riflettendo moltissimo, perché simulazione e imitazione, finzione, non è esattamente una finzione la simulazione. Comunque ci si chiede molto se le AI possano effettivamente in qualche modo simulare, riprodurre il comportamento umano fino addirittura alla coscienza. Però ha veramente senso chiedersi se un'entità, se quella che potrebbe essere un'entità digitale abbia una coscienza come quella umana? Non è forse anche un po' antropocentrico come ragionamento? E poi un'altra riflessione. Cos'è la coscienza? In realtà non lo sappiamo bene neanche noi.
Filosofia pura, no?
Parliamo di qualcosa che noi stessi umani, diciamo così, non conosciamo ancora molto bene. E se la coscienza potesse emergere, non lo so, sono tutte riflessioni, potesse emergere da sistemi complessi.
Sì, scusami, mi chiedono volevi
You have
dire?
an answer for Piero?
No, okay, no, okay, it's a complex topic.
Also that is a question.
Yeah.
And these are reflections we probably.
Questo è nel senso, what is the possibility? In the sense, typically, if you have to make I'm not an expert in this, if you have to make an operation, okay, with the computer, you have to use some amount of energy, in the case of AI, at least in the configuration that we are using nowadays, they have the feeling that there is more energy of the result that appear in your place. You have shown the case of the picture of the couple of persons without transformer. I read something about this. The amount of energy that is requested to produce one of these images is really impressive.
It's I think
This is the future. This is the possibility to produce the amount of energy that this technology is requesting.
well, it's a good point. It's crazy because, for example, some days ago I read, and I never thought about it, but it's really simple that even if when we say thank you to ChatGPT, we consume a lot of energy. It's crazy because we put somewhere like a word. This word is calculated inside the large language model, which reside on some data centers around the world. It's crazy. And maybe for even for stupid things, I wouldn't say it needs to be forbidden, but something like this because for an environmental.
Also, because it's sometimes because as I shown properly, your talk was very nice. These technologies nowadays also used in common users. For instance, all the programs that we have used for modifying images include AI inside.
Yeah.
Use a lot of Photoshop and Lightroom, for instance. And there's some tool that you can use for generate object inside image or remove an object inside image. And if the network is disconnected, the program really crash. If you are making an operation using the AI, the network is interrupted, your software is completely stopped, and you have to do also the computer sometimes.
Our notebook are not able to perform this kind of operations. Some of AI operations. At least maybe the most simple, like tweaking an image, maybe yes, but for large language models cannot reside in a PC. But even the tools that use Photoshop or the design, they are very complex because it's something even similar to large language models because they are text to image. You see, insert this object, and they are the amount of energy and power is crazy.
There is another question from Oscar.
Ciao Stefano, a very
simple curiosity.
Yeah.
Do you know if the Turing test has been applied to probe the intelligence level of ChatGPT, Copilot, or Gemini?
Yeah, I think that there are a lot of papers which are dealing with this thing. The problem is that Turing test is showing some age. I think it's not real suited for testing, for benchmarking our models, because Turing test was really simple, and the amount of complexity and different results that have these models like ChatGPT require more sophisticated tests. So you can find many.
Yeah, but the advantage is in its simplicity, actually.
Yeah, but as I said before, it's strange because for some tasks you cannot distinguish ChatGPT from a human, but maybe for simple
Not
tasks,
in general, yeah.
For simple tasks, it seems obvious that he is a calculator, because I think that the model inside the problem is not rule based. It's the same argument as before. It's not rule based, but it's statistical. So it's totally different from our brain. That's the point.
Mauro, last question.
Okay. I know your work. Just to mention that, of course, you showed the basic lines, but for example, with reference to the nature of the statistical algorithm, we have learned that there are many variations of the applications. And your university teacher showed us that some of our applications can be developed under the physical model system.
Yeah,
machine learning.
So I still haven't started this kind of things.
But with the underlying physical model.
Yeah.
And you work at an advanced stage of knowledge of the system and so on.
Yeah, they invented these kind of networks that they don't, like Mauro said, they don't start from scratch from random inputs or random self-representation, but from a real physical model for some kind of task. So I think it's an interesting field.
Also in this case, this can apply because some teams from China have developed a similar approach for really different images, and they consider the statistical distribution of noise. So there is a mathematical basis. But okay.
Okay, let's thank again Stefano. If you have questions, we can stop emails already these days. And next meeting